Hey everybody, today is January 24th, another day for a Leetcode problem. We're going to go ahead and do our warm-up real quick and get the problem. Ooh, okay. Let's go ahead and look at the problem of the day. Doo-doo-doo. Find the eventual safe states. Okay. 802, find eventual safe states. There is a directed graph in nodes with each node labeled from 0 to n-1. The graph is represented by a zero-indexed 2D integer array graph. So it's an adjacency list where graph I is an integer array of nodes adjacent to node I. Meaning there's an edge from node I to each node in graph I. A node is a terminal node if there's no outgoing edges. Okay, so we're probably going to be doing in degrees out degrees. A node is a safe node if every possible path from that node, every possible path leads to a terminal node or another safe node. All right. Return an array containing all safe nodes of the graph. The answer should be sorted in ascending order. Okay, so you have 0 goes 1 to 2. Node 1 goes 2 to 3. 2 and 3. Node 2 goes to 5. Node 3 goes back to 0. Interesting. So anything in this cycle isn't in here. They're labeled n-1. We could technically do a for loop with a scene vector, and any cycle we find we eliminate from this, right? Wonder how harder it would be to write like that. I think. I could do DFS or BFS, right? DFS would probably be more appropriate. Um, it's not Well, okay, so is O, so this is the number of nodes. Well, I'm not going to do anything else. I can just do it like valid. And then it's going to be a graph size. And I'm going to say they're all valid to start. But then we can also use a vector scene size. Oh, wait, no. Hold on. We basically want to do a for loop through graph.size, right? Size plus and then we can say something like if valid. So it has to the node has to actually be valid to do what I'm trying to do. We can check for cycle, right? Which is what we're doing. And we can basically use a, so if the node is valid, we want to check cycle. If cycle at node I, and node I and, was it valid? Would valid work? Because we don't want to obtain anything that's not valid. But could you have a node? Basically, all paths have to lead to safe nodes. If any path along this thing does not have a safe node, it's considered a invalid node, right? And if you find something invalid, there's no reason to check. But is everything along the line to the cycle considered invalid? Yes. We're gonna say valid, just valid, right? And we should pass a graph. Graphs are adjacency list. Okay, if this returns true and there's a cycle, then yeah, because if you hit an invalid node, it's automatically invalid and it can be returned, which is why I'm going to pass it into cycle. If you don't find it, but you find a cycle, then you still need a place to keep all the invalid stuff, right? Along the thing. Which means we need a running list. Yeah. Vector int list. Say list. Or no, let's say path. Yeah, because there's a path that it would be invalid. but doesn't mean that the path from here to something is invalid. Just this path, right? Okay. Yeah, so we basically want to make everything on the path invalid, right? We'll just go for auto. It's containing indexes, path, valid I, or no, valid P equals 0. Right. So if there's a cycle, or it's invalid in some way, then you take everything on the path that you just found, and then mark them as 0. And then at the end of here, we just say the result is everything valid, which is going to be in order, vector int result, or auto invalid if v result dot push back, and this is just going to be the index. Wait, no, I'm sorry, can't do that. Int I equals 0, I less than valid size plus the I pushback I, and then return the result, right? So yeah, so we could just do this. Then we need a cycle, which is going to be probably like a DFS style something, which is going to take okay, valid is the vector bool valid. So we have graph vector graph, and then we have vector and path. Wait, hold on. So maybe we shouldn't instantiate a path like this. Oh no, we need to, huh? If I don't do it this way, then I won't be able to return it like this. So it needs to be a reference. But there's branching. What if there's multiple cycles? Oh, it doesn't matter, does it? Well, no, it does. Okay, well, we'll just go from here and see what happens. Okay. So basically, what do we do now? We want to, I know that we want to go to its neighbors. As less than, was it graph.size, or no, index.size. Okay, so not sure if I'm going down the right path, but let's see what we can do. Well, first off, what we can do is if valid IDX, if not valid, return false. That should help first. Then we want to go through each value. we're going to go bool state true. If cycle idx. Wait, how is this going to help me? I need to know if I've seen something before along a path, right? So we have a vector int path. And this path is going to start out as zeros, but it's going to be graph.size, right? So graph or path idx is 1, right? Let's just change this for a minute. I think I'm gonna do this a different way. So we're on a path starting at 0. We wanted to go from 0 to 1 and 2. So here's my graphs adjacency list. If no. How do I want to do this? Maybe I could be like state equals cycle graph. Oh, no. Sorry. Oh, yeah. So the new index is going to be graph idx I. Valid graph. Okay, so we want anything that's going to be false, right? Which is the exact thing of and. So if I do and equals, the only way this is true is if this state is true. If I ever find a false, they're all false. Okay, yeah, so looking for an all and states for validity. If not state, break. So if the state is ever false, just break out of the loop, the adjacency loop, because we don't need to look anymore. And then return state, right? Wait, if not valid. Wait. We mark the path. If it's not valid, return false. Check all paths. Okay. And we still need something if we return a terminal node, right? So if graph idx. So yeah, if the index that we're on has nothing in the adjacency list, dot size 0, return true, right? And then okay, so if path j equals 1, then valid j equals 0. Right? Something like this? Oh. Yeah, I figured that might happen. I wonder why this is going out of bounds. Oh, we need something to check if path. It should always be a new node, right? If path IDX, which we found cycle. We want to return false. It's already in the path, so we don't need to label again. Oh, 1, 3, 5, 6. 2's not in here. Wait, what was invalid? Hold on. If not valid, if path IDX. 0 goes to 2. 2 goes to 3. Wait. Zero goes to 1 and 2. Okay. 2 goes to 5. 1. Okay. 0 goes to 1. 1 goes to 3. And 3 goes to 0. So 0, 1, and 3, these 3 are invalid. And these 2 are invalid. How did I get those flipped? If cycle. Wait, hold on. I think I'm doing this backwards, aren't I? If not cycle. Okay, that's closer. How am I missing 2? Is it because it marked 2 on the way there? Hold on. Let's see. So I'm marking path for this node. I'm doing this. Maybe I should be unmarking path. Right? if state is true, or no, if state is not true, no, if state is true, then unmark the path after we did the DFS. I don't think that's going to help. I mean, it did help, but that's kind of like backtracking a little bit. I don't know if this is going to function. TLE. Let's see. If valid. Hold on. If there's ever a cross edge, or not a cross edge, a back edge. I mean, okay, so this solution works. It's just taking too long, and it's because it's backtracking, basically. Is there a way to make this faster? State. If you find a false, if not state break, I could just say return false. But then I wouldn't unmark it. Yeah. If you go backwards, I'm trying to think of how this could be done faster. Valid. I'm passing invalid. So what if instead of the path, okay, so I'm doing this for this, but what if I flip it around? Oh, no, because they're all valid. Start. How would that help me? I think this is a part of why it's so bad. This is pretty much just however many nodes there are. You mark the path. Okay, this basically guarantees that you're going to find the path through backtracking. No, I think I'm going to have to find a different alternative way of doing it. Because I can't think of a faster way of doing this. Hold on. What did I took out? One, made them all valid. What if I'd made this a universal value? I don't think that's going to help, but... I mean, these are all references anyway. Right? Shouldn't be making any copies. Okay. There's got to be an easier way to do this. You have... Ooh. I mean, okay, so here's the thing. The way they have this lined up and the arrows, they make it sound like it's a topological sort. But I'm trying to figure out how the topological sort would work in this problem. Because you're going to have arrows going back. And aren't cycles like a part of it? Let's see. If we wanted to do a top sort, we would need to find everything with 0 in degrees, which is 6 and 5. Or no, we flip them all. So 1 and 2, 2 and 3, 4 is 1. Okay, so 4 and 6 would be our 2-degree nodes. And then if you take out 4 and 6, we'd be left with 5. Right? And then if you left out 5, we'd be left with 2. If you left out 2, that would be it. From the only ones of those. Oh, because the cycle wouldn't even be a part of it. Right? Okay. I was kind of hoping not to have to write a top sort. but let's do it anyway. Let's go ahead and erase our current work, which worked. It's just not efficient enough. Okay, so what do we need? We need in degrees. Right? And the way I do this is I flip the graph to do the top sort. So for in degrees, it's the out degrees, I think. Yeah, so say like 4 goes to 5, it's actually going to be 5 goes to 4. That's going to be an in degree, or no. That's an out degree of 1. So I'm just going to look for anything with in degree of 0. Yeah, that works. So in degree of 0 would be 4 and 6. Okay, so graph dot size 0. Then we're gonna go 4 0. Then size. Which is the adjacency list. Wow, I haven't done a top sort in a long time. And usually they just give us, they don't just give us the adjacency list, so it's kind of, do I just go through each adjacency list? Wait, hold on. So, 4 has there's 0 4s in here and 0 6s. So 1, 2, 3. Or I'm sorry, 0, 1, 2, 3, and 5. Right? J is less than graph. Plus. And it will say in degrees of node I. No. So in degrees of 1 is plus plus. So graph. No. Yes. Yeah. No, yeah. Graph ij plus plus. Yeah. So 1, 2, 2, 3, 5, 0, 5. Okay. So this gives me in degrees. So then we just need to do a breadth first search of the graph. Right. If in degrees equals 0, then keep off push, right? So like 4 and 6 are going to be the things that have an out degree of 0, or no, an in degree of 0. Yeah. So if there is nothing coming into the node, it means it's a root node, right? And we just want a BFS from the root node. Or no, we want to eliminate that. So we would go, hold on. So if we said 4, 0, 1, 2, 3, 4. So 4 goes to 0. So we want to check nodes of 0, right? So we go to node 0. We say eliminate the path from that node, right? At node 0. Oh, wait, that's wrong. I'm sorry, 5. Yeah. I'm sorry, at 5. So we eliminate 4. And now this is an in degree of 0, which means it's pushed on to the result. Result. I think we can assume that all these nodes are probably fine. Right? Okay, so then we're going to go, that pushes them all, not q.empty. Okay, so you eliminate 4, you get 5. Okay, you eliminate 5, you get, or no, then you check the adjacency list here because it's now the same thing. Then you get 2. And we only do it if it in degrees hits 0, right? Now this is sort of, I don't think it really matters in what order we do it. Because you're just eliminating paths, right? I feel like I could just say result dot push back q dot front. I did this so wrong. In u equals q dot front, q dot pop. Result dot push back u, and then we need to go through the adjacency list. So graph auto, we can do that, right? Graph u. And then we could go, well, if we do this, I don't actually need to do that. We can just say in degrees adjacency lists. So the new node, you want to subtract. And if in degrees adjacency node, should I do it before or after? Well, it doesn't matter. So we subtract it. If it equals 0, we just want to push this new one onto the thing. Because once it hits -1, it's not going to matter. Right? And then, yeah. So that should make everything that's valid. And then we should just be able to return. Oh, no, no, no. Hold on. This might come out of order. Top sort doesn't guarantee the order. Yeah. So we just want to sort int and return result. I got 4 and 6. And then nothing else. In degrees adjacent. If in degrees equals 0, we want to push it to the Q, which we didn't. Okay, we pushed 0 and 0 to the Q, right? We then said, say we're on 4. Okay. We want to take the in degrees of 5, subtract it 1 because of the 4. You should get 0. Push that onto the Q. Hold on. I need to make sure this is doing it right. Okay. In degrees. So adjacency. So we 5. Okay, so got the 5. Five has 2 things coming in. One from 2 and one from... Oh, hold on. Node 2 goes to 5. And 4 goes to 5. So even if we eliminated 4... Okay. There's still node 2. Is it because I didn't flip the graph? Let's do this. Vector, int, reverse. And the reverse is still going to have the same graph. Dot size for the number of vectors, but I want to let's see, in degrees graph, I is the node. So say if we were checking node 0, we actually want to take the node from J. So graph IJ. The thing in here is the node. Dot push back to... Yeah, so 1. We're going to push back 0, which is I. right? So 1 goes to 0. And then instead of using graph, we use reverse. Right? What did it see out? Output? Wait, it didn't even see out the adjacency node. Yeah, so graph ij. J is a thing in here. I is this. Okay. Hold on. Maybe I have to do it completely off the reverse. And I'm just kind of... well, no, hold on. I can do it this way too. This is the reverse, right? You're telling me I don't want 4 or 6 then. But I want 5 and 6. Because it's a no outgoing nodes. Which means this would be 2, 2, 1, 1, 1, 0, 0. If you go from 5 and 6, you eliminate 5. You get 4 and 2. I mean, it would work for the same, I guess. Graph ij plus plus. I, j. You give it 1 and 2. Instead of doing it this way, I could just do it this way. Yeah. Yeah, that's kind of what I was looking for. Maybe I just wrote it wrong the first time. Okay. Yeah, and then it just doesn't include anything in a cycle. Yeah, I guess that's how it's done. Well, I mean, there's obviously another solution, but... Alright. So it's a top sort problem. Thank you guys for joining in on me. And I hope you have a wonderful day. Peace.